For my AP Physics 1 CDU, which was the project of taking anything we learned from marking period 3 and showing our knowledge of it, I previously, before the class, built this wave pendulum without actually knowing how it works. But now that we've actually learned about simple harmonic motion and more about pendulums, I'm going to attempt to explain how this wave pendulum, which is a pendulum set up in a series with very specific lengths, so that after a period of time they all synchronize back up. I'm going to attempt to explain that. So to first start off, I need to explain what a simple pendulum is, which I have written here on the board. So a simple pendulum is just a pendulum, which is a string with the length L. It can be any material, like a rope or a string, and a mass, M, on the bottom. And when the mass is pulled back, it changes by theta, and when it's pulled back and released, it will oscillate, and it will travel to the other side. So it will go down and back, completing an oscillation or a cycle, and that is what makes pendulums a perfect harmonic oscillator. But in reality, they actually aren't, because every time they oscillate, they do lose a little bit of energy due to friction, so it doesn't actually go back the exact same distance like it should. And also, with pendulums, if you when you start to increase theta past around 20 and 30, it doesn't really work as well. So it's not the greatest simple harmonic oscillator, but it is pretty good when you're working with small thetas. So to describe the position of the mass, the equation x equals a cosine omega t. This equation basically describes the x position of the mass, not taking into account y, just horizontal, but amplitude simply is just the maximum and minimum displacement that the mass can move. Omega is radians per second, which is angular velocity, and t simply just stands for time. To solve for the velocity, the equation E equals negative amplitude, negative a omega sine omega t is used to solve for the velocity, and for acceleration it is just negative a omega squared cosine omega t. So these are the equations that we use for solving for the mass, but something that's also important is the period. And so the period is the time that is needed to complete one cycle. And so this is where it starts to move more into how to make the pendulum wave. So with period for pendulum, we have the equation t equals 2 pi the square root of LG, and and so this equation can be used to solve for the period when you know the length of the pendulum. And obviously, you know gravity because you probably won't be dealing with a pendulum outside of Earth's gravity, which is just 9.8 meters per second. But that is how you solve for period. But if we wanted to do the opposite and solve for length, if we knew the period, we could rearrange the equation with some algebra, which is just t divided by 2 pi, just taking 2 pi, dividing it on both sides, and then square that by squaring the L divided by G with the length divided by gravity. And then once you just have length divided by gravity on one side, you multiply by gravity, which is G, and you get length. So this equation can be used when you know the period of the pendulum, but you don't know the length and you want to solve for length. So where this ties in with the wave pendulum, it comes from a more complex formula, which is very similar to this one, which is just L with N is G T max 2 pi brackets K plus N plus 1, close off these brackets, and you square that. So everything is squared except for gravity. And so basically what this equation means is T max is the overall cycles in seconds. So the overall time you want. So if I wanted all the pendulums to resync after 30 seconds, all I would do is just plug in 30 seconds. K is the number of cycles the whole apparatus will go through, or the number of cycles the whole apparatus goes through to repeat the pendulums. So, and I'll keep explaining. So N is the number of the pendulum that you are on. And so basically, if to first start off with this equation, you have a set length, which is what you decide when you make the first pendulum. So you would measure out the length in meters, and you would solve for K, because K is a constant. So you would plug in your length, 9.8 meters per second, whatever you want T max to be, which could be 30 seconds, and you solve for K. And then once you get K, K is constant for the rest of the equation. So K is just going to be the number of cycles for the first pendulum. And then as you increase N, so as you start to solve for the next pendulum, so for the second pendulum I would plug in 2, the number of cycles will increase. So if this had 20 cycles, this one would have 21, 22, etc., etc. And you calculate the length to get the right amount of cycles, so then you can have the same period for all of them. So after a while, so after this one does 20 cycles and this one does 21, they will sync back up right at 30 seconds. Obviously, this is a little more complex than just AP Physics 1, and it's more of a upper physics concept. But I basically showed how the two equations relate, because they basically are the same, and all you're adding is this bracket part right here, which is K plus N plus 1, and you're changing period to T max. But they are very similar, and it shows how just one simple pendulum can then be related to different equations and how they're all related. So to end off the video, I am simply just going to let the pendulum play off until it becomes chaotic, because in reality it is really hard to get the exact measurements for these pendulums, and so over time they start to become out of sync. But at the beginning it does look pretty cool. So thanks for watching.